All right, good morning. My name is Ali. I am with Özyeğin University. And this is a joint work with two undergrad students. And this is not the slide. Can you open the other one? This is the fourth talk. You need to open the sync play one. I have two talks in this session. So this is a joint work with two undergrad students who just started their PhD in Concordia University, actually, in Canada. And Zafar is one of my current PhD students at the back who's going to show the demo. So let's start. We are going to talk about sync play, and this is, as the name implies, is synchronized playback. And we are going to do this with MoQ transport specifically. So the social viewing is something becoming really popular. Apple has this Apple Share Play. There are watch parties like from YouTube, Netflix, and so on. And then there are many other websites that offer similar experiences. So people get together and then they watch the same content, usually a movie, but it could be a live content as well, right? And, they just enjoy the content at the same time, despite being in different places. Now, the whole idea is really sharing the emotional context, right? They would like to laugh at the same time, they would like to get upset at the same time, and so on. And synchronization is, that's why it's a bit important. We don't really need frame-accurate synchronization, but it needs to be pretty accurate in terms of like, I'm not gonna see some action like seconds before you do, right? That's important. And the research has shown that with this type of synchronized playback experience, like share play and so on, engagement actually increases, and the return, you get to keep your customers, which is a good thing. Now, the problem we are trying to solve is as follows. So there might be multiple viewers across the world, right? They don't necessarily need to be next to each other or nearby. For example, in this case, we have a relay in Frankfurt in Germany, and then we have some clients, the viewers in Istanbul, and then all the way in Canada, Vancouver on the West Coast. So even the round trip time between these two locations is going to be multiple hundreds of milliseconds. So achieving some sort of, again, not frame accurate synchronization, but really within a tolerable window, it's a challenging task. So we would like to be, we would like to have high synchronization fidelity. We would like to also have, a highly scalable system. And when you look at the previous studies, including from TNO, for example, Rob used to be, working at TNO. So anything less than 200 milliseconds is socially transparent. So as long as we are within 200 milliseconds of delay between the viewers, we are fine. Acceptable is less than half a second. And anything more than half a second becomes a bit noticeable. And then, maybe there will be spoilers and, things are not going to be really that much engaging. So we first solved this problem, actually more than a year ago. And we used the existing MoQ APIs. And then at the time, it was just subscribe. There was no fetch. And the way this actually worked was, there's a leader in the room who's going to control the playback. It can seek back and forward, right? And then everybody else is a follower. We have a room management server that is running over WebSocket. It's just the way we picked. And then we have a relay, and then there's a publisher. And the publisher has to be room specific because it's controlled by the leader's actions. And then, whatever actions like seek, pause, resume, it goes to this room specific publisher and then other followers so that they get to get synchronized very easily. Now, there were a lot of disadvantages for this approach. We knew the disadvantages, but that's what we actually had in the first place. So first of all, in this case, the publisher is room specific. So even if there are other rooms that are watching the same content, there had to be different publishers for each room. And the caching efficiency is lost because now content is really duplicated across the rooms. And the QoE was quite fragile. So in terms of any variability in the jitter would actually result, especially if there was some problem over this link, it will actually lead some QoE issues. And then a strict timeline enforcement and lack of independent playback. So if you are a follower, you are supposed to keep track of the leader. You cannot really do anything independently. Yes, the idea is to watch something together, but we still would like to maybe sometimes replay a specific portion and then get back to the watch party. Now, with the Fetch API introduction that came in version 7, we changed our architecture. Now there is a common publisher across all the rooms watching the same content. So there could be hundreds, thousands of rooms, and there are still like leader and followers, but this is not room specific anymore. So the system is highly scalable. And by using the Fetch API, we can actually use the relay as a cache as well. So everybody who is watching the same content can use the same cache. The QoE has improved significantly. And then we also have the capability to do independent playback. So for a short amount of time, you can get out of the synchronization, watch something yourself, and then get back onto the track. So the way we implemented this is all open source in our MoQ repo. We have heartbeat signaling that goes from the leaders periodically to the followers. And this is going to tell you each follower where the leader's current position is, right? Depending on that, you need to maybe adjust your playback speed, and you need to get on track with the leader. We have a synchronization logic, so things can happen. Maybe your Wi-Fi is going to go down for a few seconds, or maybe the leader's Wi-Fi is going to go down for a few seconds. So you need to keep people in sync, and that's why we have the synchronization logic. So if the difference between the leader and the follower, let's say you are the follower, the difference between you and the leader is above a certain threshold, we actually force a jump, involuntary jump. So you just seek forward or backward. But if it is within a reasonable window, let's say 200 milliseconds, then you're in sync. If it is somewhere in between the minimum threshold and the maximum threshold, then we actually play some play speed tricks to get back on track. And then if the leader is actually moving around, this is an on-demand content, right? You can go, backward or forward. The followers are gonna follow you as well. Okay, this is a demo time, and let's switch the screens. And hopefully, I'm gonna join the session here as well. Let me give a second. So, let me just join over here as well. Okay, so I'm going to put my computer here. Hopefully you will be able to see it. And then speak back money. So one of these guys is the leader, the left-hand side. Zafer is running 2 clients on on 2 browsers over there. And so this guy is the leader. So, it picks the content, right, from the library, and we currently have only Big Buck Bunny in our library, but you get the point. So you are broadcasting. So the guy on the right-hand side is the follower, and I'm also a follower over here. So I don't see it, but hopefully these are all synchronized. So at the moment, let me get back to the mic. It says in sync, so I can't really read the number. Can someone tell me what it is? How much? 170. Okay, so that's within our threshold. So it's just, I think this is 25 frames per second. So you are going to get about 40 milliseconds interframe time. And then this is like 3-4 frames. So that's relatively reasonable for social viewing. So I can also check this one. This is 156. So depending on the Wi-Fi and everything, obviously it moves around. But as long as it stays within the threshold, minimum threshold, then you are okay. So Zafar, can we click on the settings here? So let's say you are in an environment where the conditions are not really that great. So you can adjust your own thresholds. So if you are okay with a bit, being further away or further behind than the leader, you can adjust these thresholds accordingly. So in this case, I think this is 200 at this point, default value. And then this is 1 second. So anything above 1 second is going to enforce you to the involuntary jump with the current playback position of the leader. And then the playback speed is, the variation of the playback speed if you are within the between minimum and maximum thresholds, okay? So we can have as many viewers as we would like to. This is, the content is coming from the relay. In this case, it's in Frankfurt. So we are in Denver, so that's already like, almost 150 milliseconds one-way trip time. And another feature, can we click on the standalone playback? So, and now you get the full control over the media timeline, and then you can seek backward and forward. So maybe you got bored of your leader, right? So you don't want to watch the content yourself anymore, or you wanted to replay a portion of that, so you can seek around, and then once you are done, you can go back and resync with the player. So once you are resync, it will jump to the current position of the leader, and then you are back on track. Again, we can have as many viewers we would like to, and the content is already cached in the relay, so it is pretty straightforward from that point on. And then if you are done, if you leave the room as the leader, then someone else is going to be the leader, and then they can continue the social viewing. Any questions before we move on? Yes, sir. Yes.
Why there's the whole discussion of caches and stuff. I mean, if you tell a player you want to be playing at this position, then is there more to it than that?
Yeah, but the content is being streamed from the relay, right? It's coming from a server. So if the leader, for example, jumps forward, that's not already in the player's playback buffer. You need to get it from the relay, right? And then all the followers will follow the leader, so they will also get it from the relay. So we are not going all the way to the origin, the publisher, right? We are getting it just from a nearby relay. So this is just like how you will do it with Dash or HLS. I mean, this is not something new. I mean, we are just trying to show that MoQ, or MoQ transport is originally designed for live or low latency live streaming, but it could be very well used for on-demand and then even further for synchronized playback if you want to. So, I mean, this is really like an illustration of, the power of MoQ in terms of capabilities. Yes, sir. Alex? Yeah.
So two questions. First, to how many nodes did you schedule this? And secondly, does the leader know what the latency of the peers is?
Does the leader know what?
Does the leader know what the latency of the peers is?
In our testing, I think went up to all the way to 25 followers. I mean, we can try more, but then we need volunteers to actually, to join the room and do some testing. And the second question, the leader is not really aware of the followers or the number of followers. It's just sending a message back to the room server, and then the room server knows exactly who is in the room, and then it's going to propagate that heartbeat message back to the followers. Now, there is no latency feedback coming from the followers to the leader. The leader doesn't care about that. You could. But then how would you use that information?
So if the leader needs to know if everybody is following, so he likes to have an overview of how the audience is, how close they are.
Okay, yeah. This is probably more related to my second talk, so let's get on this in the second talk. Any other question? Yes. Well, the leader is watching only one video at this time, so that's what's synchronized. So are you asking whether the leader is watching like 2 videos, and then we would like to?
It's multi-camera. It's a multi-camera question. Can you use
like multi-view? Yeah, definitely. I mean, definitely. It's just there will be 2 video players, 2 video elements, and 2 heartbeat messages, or 2 timestamps per heartbeat message. Another question? No? Oh, yes, Cyril.
Just to make sure I
No, it is not. So that part is actually managed by the room server that's running over WebSocket. That has nothing to do with MoQ transport.
So you could do the same demo using that overlay and then use chunk transfer encoding and do the same, right?
Sure, sure.
So Ali, I think you used up your time.
Yes,
with
I
the
did.
question.
Can
But
I
you
use-
had questions. So
Can I use one more slide?
yes.
All right. All right, okay. Let's move on. There are some papers, this is a full paper for this conference, so there are some results. I'm not gonna go in them. So we have some statistics in terms of delay distributions, latency deviation, distributions and so on. And this is showing how sensitive we are to the threshold, like when we force a jump. So if you reduce it a bit, so you will really wanna be tightly synchronized, then you are going to be enforcing a lot more jumps. But if it is like over 500 milliseconds between Istanbul and Vancouver, there were no involuntary jumps. And one more thing, yes, so this is the source code, this is the issue tracker, this is what we are working on now. Actually, as of a couple of days ago, the first item has been implemented. So we have this dual shift, dual threshold drift correction, and then other things are in the pipeline. Thank you very much.
Thank you.